Lesson 11.2, Task 1. Graph simple rational functions. All right, graph and analyze f of x equals 1 over x. All right, if you remember, a rational expression or a rational number is a fraction. It's something over something else. So to graph a rational function, it's going to be in the form f of x equals px over qx. So it's going to be in fraction form, where p of x and q of x are polynomials and q of x is not equal to 0. Remember, you can't have a denominator equal to 0. You've already graphed rational functions of the form f of x equals a over x that model real-world situations for which a is greater than 0, and the domain is restricted to x greater than 0, or positive numbers. Such graphs lie in the first quadrant. In the next task, you will graph a rational function f of x equals 1 over x when the function's domain is not restricted by real-world considerations. All right. So this is the graph where it's been restricted, and we're going to move into looking at where it's not been restricted. All right, so it says, is the function f of x equals 1 over x an odd, an even, or neither? Give a mathematical justification for your answer and explain what your answer implies. All right, so let's graph a rational expression or a rational equation here without the restrictions. So if I put in 1 over x, which I already have here, and I hit graph, you can see that it's the part here that the picture gives us, but then it's got the other part. So there's two different parts, and you can see that is a reflection across the origin. So this would be considered an odd function, okay? Even would be a reflection across the y-axis, and this one is a reflection across the x. All right, let's see what answer they give. The function is odd. F of negative x equals 1 over negative x, which equals negative 1 over x, which equals negative f of x. This means the graph is symmetric about the origin. All right, so that's a little bit more complicated than just saying if it's a reflection across the origin, it is an odd function, and you can see that this is a reflection across the origin there. All right, so the part of the graph of f of x equals 1 over x that lies in the first quadrant is shown. Use your answer from part A to draw and complete the graph of f in the coordinate plane that shows all 4 coordinates. Okay, so I graphed that on the calculator, and it's going to look like this. Okay, so the difference of this and what I have on the calculator is this is a table of 10 by 10, and it looks like they've got 5 or 6 by 6 here. So it's just a little bit more blown up. Same graph though. All right, so it says identify the following key features of the function. All right, so the domain is approaching 0, but it doesn't get to 0. Here it's approaching 0, but doesn't get there. And the y is the same thing. So the range and the domain, they're both approaching 0, but 0 is not included. So basically it's all real numbers except 0. So the domain are your x values. So x's such that x is not equal to 0. That just means all real numbers except 0. And the range is the same thing except it's your y values. All right, your vertical isotope is right here, and it goes through x equals 0. And your horizontal isotope would go through y equals 0. I put the wrong thing in for that one. All right, so your vertical isotope goes through the x. The horizontal isotope goes through the y-axis. All right, describe the end behavior of the function f. All right, if we look at the function f, the end behavior as x approaches infinity, as x goes to the right, this approaches 0. And as x approaches negative infinity, or as it goes to the left, it also approaches 0. So both of these approach 0. All right, identify the intervals where f of x is positive and the intervals where f of x is negative. All right, so x is positive for everything above 0, and it's negative for everything below 0. So this is going to say f of x is positive from 0 to infinity. That's true because it's above the x-axis. And it's negative from 0 to negative infinity because it's below the x-axis at that point. All right, so it says the function is positive for positive values of x and negative for negative values of x. So again, when it's above the x-axis, it's positive. When it's below, it's negative. Identify whether the function f is increasing or decreasing on each interval. All right, so if we look at the graph again, you can see on this interval it is decreasing, and on this interval it is decreasing as well. So you always read your graph from left to right. So it's going down and it's going down. So we can identify that f is decreasing on the left side of the graph. Negative infinity to 0 is the left side, so it's decreasing. And it's also decreasing on the right side. All right, that's all for task 1. If you have any questions, please let me know. Lesson 11.2, task 2. Graph simple rational functions. You can apply transformations to the graph of f of x equals 1 over x to produce a new rational function g of x. The tables describe the information you can gather from each parameter in g of x. Notice that the isotopes are affected only by h and k, while the reference points are affected by all 4 parameters. All right, so this should look somewhat familiar. We've got an a 1 over b, an h, and a k. So these are the same transformations that we've used in other functions. We're just now going to apply these to rational functions. Okay? All right, so f of x, your parent function here, this is your vertical, your horizontal isotope, and your 2 reference points. So this is for your parent function. Then we're going to have a transformation, and your transformation is going to move your vertical isotope to h, whatever h is. Then your horizontal isotope will move to k, whatever k is. And then your new reference points can be found using b and h and a and k. Okay, so you just have to use those to find your reference points. All right, so it says consider the function g of x equals 3 times 1 over x minus 1 plus 2. I'm going to write that down. Okay, I've written that down here, so as I scroll down, I can have this when I need it. So it says, what transformations can you apply to the graph of f of x equals 1 over x, or the parent function, to produce g of x? Okay, so this shows us that our a is 3. The 1 over b, there's no b, and this would be h, and this would be k. All right, so that would be the different transformations that we will apply. All right, now it says, what are the reference points on the graph of g that correspond to the given reference points on the graph of f? All right, so if we go back above, we're also given the reference points here. So let's look at our reference points. So the first reference point is going to be negative b plus h, and negative a plus k. So this is your x and y. This is just an ordered pair. And then we've got b plus h, and we've got a plus k. So that's how we're going to find our 2 reference points. All right, so first we have to look at g of x. And I already kind of stated that a is 3, okay? This comes from the general formula. B is just 1. There's no number there, so you assume it to be 1. h, it's always minus h, so h is just 1. And k is 2. All right, so now that we have a, b, h, and k, we're just going to use these reference points. So I need negative b plus h, negative b plus h equals 0. So this first point here is going to be 0. And then to find negative a plus k, negative a would be negative 3 plus k plus 2. Negative 3 plus 2 is negative 1, so that would be negative 1. So that's my first point. I'm going to go ahead and find the second point, so I can type them in at the same time. So I need b plus h. b plus h is 1 plus 1. And that's this. And then a plus k is 3 plus 2. All right, so I'm going to go ahead and put in my points here. So I'm going to have 0, negative 1, and I'm going to have 1, 5. Did I do that wrong? Let's see, a plus k. B plus H. Oops, I added 1 plus 1 wrong. I didn't add it wrong, I just put it wrong in my ordered pair here. Alright, so I wrote 2 over here, but I transferred it wrong. Okay, so my 2 points again are 0, comma, negative 1. And the second point is 2, 5. All right, that's better. All right, so the next question says, what are the isotopes of the graph? Okay, if you remember, the isotopes come from your h and k. So your isotope, your x, your vertical isotope is h. Your horizontal isotope is k. So a vertical isotope is h, which is 1, and our horizontal one is 2. So our vertical isotope is 1, horizontal is 2. All right, what is the domain? Okay, the domain is going to be all real numbers except this number here. Wherever the isotope is, that's what's excluded. All right, the range is all real numbers except 2 is the isotope. So it would be all real numbers except 2. Remember, that's just a shift over from the parent function. On the parent function, it would be 0. All right, sketch the graph. If you sketch the graph, you can see it's just been shifted over and up here. And then, of course, A changes your stretch on it. The dotted lines are the isotopes there that we noted. All right, how is the graph of G similar to the graph of f of x? And how is it different? Well, it has the same similar shape. Now it has a reflection over this point, 1, 2, instead of the origin. And it is stretched, and it has a horizontal and a vertical stretch. But other than that, the general shape is still the same. All right, if you have any questions, please let me know.